What if the most elusive light show in the solar system was never truly hidden, just waiting for us to invent the right way to see it? Picture Neptune, a frozen giant, cloaked in blue, nearly 3 billion miles from the sun's warmth. Here, sunlight is so faint, it barely creates shadows. For decades, scientists imagined Neptune's auroras would be pale and rare, flickering only at the poles like those on Earth or Jupiter. But Neptune refused to follow the script. When astronomers finally glimpsed its secret glow, it was not at the poles, but nearer the mid-latitudes, a completely unexpected spot. This ghostly aurora had been performing for years, invisible to every watcher who did not know where or how to look. For over 30 years, the world's sharpest telescopes hunted for even a trace of Neptune's hidden lights. The planet stayed silent, keeping its secrets locked behind distance and darkness. Without the right technology, a key piece of planetary science slipped through our fingers, and the true nature of Neptune's magnetic forces and their lessons for other worlds remained out of reach. Had these mysteries stayed buried, we might have lost more than answers about Neptune. We risked missing clues that could transform our search for life and magnetic fields across the universe. Neptune's hidden auroras remind us the cosmos still guards secrets that only relentless curiosity and new tools can unlock. Now, with the James Webb Space Telescope's eyes trained on Neptune, everything has changed. Its cutting-edge infrared vision finally pierced Neptune's veil, and what it revealed rewrites the story of planetary magnetism. Why is Neptune so hard to study, and how did its auroras manage to elude us for so long? Neptune orbits at the frozen edge of our solar system, 30 times farther from the sun than Earth. Here, sunlight is a mere whisper, barely enough to illuminate the planet's deep blue clouds and icy haze. Every observation is a test of patience and technology. Our first close look came in the late 1980s when Voyager 2 raced past Neptune in just a few hours. Suddenly, Neptune became more than a blurry dot, a world of fierce storms, faint rings, and weather wild enough to dwarf Earth's tempests. Voyager's biggest surprise, though, was Neptune's magnetic field, huge, tilted by 47 degrees, and oddly off-center. Unlike Earth, where the magnetic field neatly matches the poles, Neptune's field is twisted and displaced. Its magnetic poles roam the surface, making auroras unpredictable and extraordinarily faint. Voyager's instruments strained to find any sign of auroras, but detected only a fragile ultraviolet shimmer lost in cosmic static. For decades, Neptune's auroras remained a rumor, hidden by distance, darkness, and tangled magnetism. The right technology simply did not exist. Yet, for such a restless planet, why did its auroras remain so secret? The quest to answer this would drive scientists to push the boundaries of discovery. Only now, with a new generation of telescopes, are we finally able to pierce Neptune's veil. With each breakthrough, the stakes for planetary science and our own understanding have never been higher. Could a phenomenon predicted for decades really be so hidden, or had we been missing something vital all along? Neptune is a planet of contradictions. Although it drifts nearly 3 billion miles from the sun, it radiates over twice the heat it receives. That inner energy fuels storms and winds that scream faster than on any other planet, reaching speeds greater than 1,000 miles per hour, hinting at a world alive with violent change. Its magnetic field is chaotic, wildly tilted, strangely off-center, and anything but stable. With this fierce magnetism and deep internal heat, scientists expected Neptune to blaze with auroras, dazzling curtains of light born from charged particles. But for more than 3 decades, those lights stubbornly refused to show themselves. Night after night, telescopes swept Neptune's blue disk. Spacecraft searched for any sign. The upper atmosphere, puzzlingly hot, should have been the perfect stage. All the pieces seemed present, but the auroras stayed invisible. The problem? At Neptune's staggering distance, auroral signals fade to near nothing. Even with its wild storms and bizarre magnetism, the glow of auroras was drowned out by cosmic noise. Some scientists feared Neptune's auroras were simply too faint to ever detect, or that our tools were not up to the task. With every failed attempt, doubt grew. Would Neptune's auroras remain a myth, haunting textbooks but never truly witnessed? Then, in the year 2021, everything changed. The James Webb Space Telescope, armed with unmatched infrared eyes, took aim at Neptune. What followed would shatter years of frustration and reveal a secret world at last. At the edge of the solar system, Neptune was about to surrender one of its oldest mysteries. The hunt for its elusive auroras had reached a turning point. Infrared eyes opened, and Neptune's secrets shimmered at last. But what emerged was more than just a beautiful spectacle. In June of 2023, the James Webb Space Telescope turned its near-infrared spectrograph on Neptune. For the first time, scientists glimpsed auroras not at the poles, but unexpectedly glowing in Neptune's mid-latitudes, a silent phenomenon hiding in plain sight for decades. A crucial clue flickered in the data called H3+. This rare ion, long seen on Jupiter, Saturn, and Uranus, had never been confirmed on Neptune until now. Its presence electrified the astronomy community, finally proving Neptune's shifting magnetic field was alive and active above its clouds. By March of 2025, the evidence stacked up. The existence of Neptune's elusive lights could no longer be denied, solving a 3-decade-old mystery. This was more than an observational feat. It was a hard-won victory for scientists who refused to stop searching. Neptune's auroras are nothing like those of its siblings. Jupiter's rage with intensity. Saturn's are gentle. Uranus's twist unpredictably. Neptune's, in contrast, are shy and displaced, dancing away from the poles, hinting at a magnetic field in turmoil. Every planet's auroras tell a unique story about the forces within. Now, for the first time ever, auroras have been directly confirmed on all 4 giant planets. The set is complete, handing scientists a new toolkit for probing planetary magnetism and chemistry on the solar system's outer frontier. Yet the implications reach even farther. Had we fallen short in technology or misread Neptune's faint clues, we would still be blind, not just to our own cosmic backyard, but to the magnetic worlds orbiting distant stars. Each breakthrough brings us closer to finding life-friendly environments or even life itself beyond Neptune's blue horizon. The hunt for these elusive auroras has changed more than charts and textbooks. It has rewritten what we expect from our exploration of the cosmos. If we can truly decode Neptune's auroras, what doors might swing open for our understanding of the universe? This discovery is not just a scientific milestone, it is a beacon guiding what comes next. The James Webb Space Telescope has only begun its vigil over Neptune. Over the next 11-year solar cycle, Webb will revisit this distant giant, tracking its shifting auroras and magnetic storms with unmatched clarity. As the sun's activity waxes and wanes, these long-term observations will reveal patterns never before seen on any planet. Yet Webb is only the first step. Picture a future mission, a dedicated orbiter, bristling with cutting-edge infrared eyes and particle detectors, sent to Neptune itself. Such a craft could pierce the planet's clouds, map its chaotic magnetic fields, and catch the very moments when charged particles strike Neptune's upper atmosphere. Unlocking the secrets of Neptune's ghostly lights would show us how magnetospheres thrive on worlds far from Earth's warmth. Why does this matter? Many of the exoplanets now being found are Neptune-like, cold, blue, shrouded in gas. If we know how to spot auroras by the subtle glow of H3+, we gain a new way to hunt for magnetic shields. Detecting this signature light years away could reveal which alien planets are protected from cosmic radiation, and maybe even which ones could host life. Ignore these clues, and we risk sending missions blindly, wasting precious years and resources. Worse, we might overlook signs of living worlds, all because we failed to read the silent language of planetary auroras. So, what will we choose to learn? And how will we act on Neptune's hidden message? The answers lie not just in data, but in daring exploration. Our next steps could reshape humanity's cosmic story. In the frozen outskirts of our solar system, even the faintest spark can change everything we thought we knew. Neptune's hidden auroras are not just a spectacle. They are proof that the universe hides truths in the places we once called empty. At last, after 3 decades of searching, the James Webb Space Telescope's infrared vision has pulled these lights from the darkness, ending a mystery that haunted astronomers for 30 years. For years, scientists refused to accept silence from Neptune. They believed something was waiting, concealed in the icy blue night, and refused to give up. Their perseverance was rewarded only because we kept building better tools and dared to ask questions that had no guarantees of answers. If we ever allow skepticism or shrinking funds to smother our curiosity, we risk losing the next astonishing discovery. Today's breakthrough proves science advances by trusting the unknown, sharpening our questions, and supporting the people and missions willing to stare into the cosmic void. If we falter, the universe's greatest secrets may slip past us, forever unseen. Now that Neptune's invisible auroras are revealed, what will you do? Will you champion science, challenge the impossible, or search for hidden wonders in your own world? Remember, sometimes the most extraordinary truths are discovered where no one else dares to look.